Welcome to Maths. My name is Semangia, the Maths Eagle. Right. So this video is on part 2 on probability, specifically tree diagrams, the probability tree diagrams. The first part, I've already done it, is there on my YouTube channel at Lakson Mangia. You can find it, look for it, and enjoy. And please, after watching this video, don't forget to like the video and subscribe. Okay, let's go into the deeper part of it. The first part that you have to understand basically is when to use and how to use tree diagrams. Tree diagrams basically, they are applied or used when there are more than there's more than one draw actually that has been made. For example, a ball is drawn and another ball is drawn. So there you can see there that there are two balls that has been drawn. So from that scenario, you are supposed to use or to apply the concept of tree diagrams. Please get that. And on that also, we have two different scenarios based on tree diagrams. The first scenario is based on random selection or draw with replacement and without replacement. That's the second part. On random draw with replacement, that one, it will never change the number of the thing that has been drawn, 1. 2, the total number of things altogether, it will not change, it will remain the same. But on the other part, on random selection or random draw without replacement, that one basically, there is the effect of reducing the number of things that is being drawn, 1. 2, the total number of things altogether, because we have picked one from the total number of things available. Right. So let's go straight into this first question. Question number 1. It says, or it reads, a bag contains 5 red balls and 3 green balls. A ball is drawn and then replaced before a ball is drawn again. As you can see, this one is a random selection with replacement, because a ball was drawn and then replaced before another ball can be drawn. So this one is with replacement. Take note of that. That's the first thing that you have to note. Then draw a tree diagram to show all the possible outcomes. Find the probability that A, 2 green balls are drawn. B, the first ball is red and the second is green. So let's draw the tree diagram based on this information given. Right, so the first part is saying a bag contains 5 red balls and 3 green balls. You write here, first you have to write the probabilities. So you say probability of red, we can use capital letter R to represent red balls. Right, so it will be equal to 5 over total number of balls altogether is 5 plus 3, which is equals to 8. Then probability of green balls, let's use G. It will be 3 over 8. Something like this. Then the tree diagram. The tree diagram, it will be like this. So let me put these dots so that it will be easy to draw the tree diagrams. That's actually what you have to do, because it will be easier for you. The first part is this one, and this one it is either, right, let me put the second part. Different ink, right? So on the first part is either you can pick a red first or a green first. Then after picking a red, you can pick another red or you can pick a green instead. Then after picking a green, you can pick a red or a green and another green. So that will be the structure of the tree diagram. Let me fill now the probabilities. Given that I am to pick or to draw a red ball for the first time, then what will be the probability of drawing a red ball? It will be 5 over 8. Then a green ball, it will be 3 over 8. Like this. Then if it's a random selection with replacement, that will not change the probabilities of the red or the green ball. Please take note of that. Then on the second outcomes, then the probabilities will remain the same. 5 over 8 here and 3 over 8 on the green, 5 over 8 on the red, and 3 over 8 on the green. So this one is the tree diagram that you are required to draw in this scenario. Take note of that, please. Right, so on this first part, it's either you can pick a red followed by a red, then on this one, it's a red followed by a green, on this one, it's a green followed by a red, this one, it's a green followed by another green. Like this. Then with this tree diagram, you can now be able to answer the questions which follows. Right, so the questions are saying, find the probability that A, 2 green balls are drawn. This one just means a green followed by a green. It's more like this part. So it's probability of a green followed by a green. How can you calculate the probability of a green followed by a green? You say probability of a green followed by a green is equals to, so you take this branch, green followed by a green, it will be 3 over 8 times 3 over 8, which is equals to, if you can simplify, it will be 9 over 64, like this. This is the final probability. Then you are done. Let's move on to the second part B. It reads, find the probability that the first ball is red and the second is green. In this case, if you can see, there is order. The first must be red and the second must be green. So it's red followed by green. It's this one. So that's the probability. That's the diagram. So it will be probability of part B, red followed by green, is equals to, a red is 5 over 8 times green, it will be 3 over 8. If you can simplify this, you get 15 over 64. Right, let's say for example, there was another part which was saying, find the probability of getting, let's say, balls of the same color. Balls of the same color. So it will be probability of either, if I can go up here, if they are of the same color, then it's either red, or green. So you say probability of red followed by red or green, which is equals to probability of red plus O. Please take note. If it's O, it's plus probability of green, like this. Then probability of red, basically on our tree diagram, it will be 5 over 8 times 5 over 8 plus green, 3 over 8 times 3 over 8, like this. Then you can simplify. Let me go this side. Simplifying. 5 over 8 times 5 over 8 is 25 over 64. Then plus 9 over 64. Then the final answer will be, you just add these values on top, it will be 34 over 64. Then from that one, you have to simplify the answer. Please leave your answer as much simplified as possible, because if it's like this, it's not simplified, so it's actually wrong. So simplify this one by 2, you get 17 over by 2, 32. So that will be the final answer based on this one. Let's move on to the second question. Question number 2. It reads, a bag contains 5 red balls, 3 blue balls, and 3 yellow balls. A ball is drawn and not replaced. So this one is random selection without replacement. Then a second ball is drawn. Find the probability of drawing the first part, 2 red balls. Okay. So since there's more than one draw, it means we have to use the concept of tree diagrams. Please take note of that. So let me draw the tree diagrams, but before that, let me write the probabilities of red. It will be 5 over total. Total is what? 5 plus 3 plus 2, which is 10. Then probability of blue, it will be 3 over 10. Probability of yellow is equals to 2 over 10. Please, 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 don't simplify these probabilities. In probability, you only have to simplify the answer. Because if you can simplify this one, hey, problem, trouble. Right, let me draw the tree diagrams using these probabilities. Let me put these first lines. And take note, please, on this part, there are 3 different balls. So it means we have 3 branches. We have 3 branches. So the first part is like this. So there are 3 branches here. Then followed by, you also have 3 branches based on this one. And 3 branches based on this one. So these branches basically, they are exactly the same as the first branch. Please take note of that. So there will be 3, 3, 3, 3, 3 is on the first part. Then from this one, I can write here it's red. Then there's blue. There's yellow. You also write red, blue, yellow. Red, blue, yellow. Red, blue, yellow. So something like this. Then filling up the probabilities. For red, first part is 5 over 10. Then yellow is 2 over 10. Then for that one is for blue. Sorry, for blue is 3 over 10. Then for yellow is 2 over 10. Like this. Then please take note of this. If I have picked a red ball in this case on the first part, then it means the number of red balls on the second draw, if I am to draw for the second time, there will be 4 because I have already picked one. So there will be 4 over 9. 9 because I have picked a red and I didn't replace that one. So the total number of balls will be reduced by 1. Then the blue balls, they still be the same. There will be 3 but over 9. Then this one, there will still be 2 but over 9. Like this. Then on this second branch, please take note, I have picked a blue ball in this case. So if I have picked a blue, then it means the number of blue balls are the one that will be reduced by 1. And obviously, the total number of balls will also be reduced by 1. So in this case, the blue balls, they were 3, they will now be 2 over 9. Then the red balls, they will still be 5 over 9. And the yellow balls, they will be 2 over 9. Like this. Then going on to the yellow one, right, if I have picked the yellow, then the number of yellow here will be reduced by 1. So it will be 1 over 9 probability. Then the red balls will still be 5 over 9. And the blue balls will still be 3 over 9. So like this. So that's the probability tree diagrams based on those outcomes. Then using this tree diagram, then you can be able to answer the questions. So the first part is saying, find the probability of drawing 2 red balls. 2 red balls. It means a red followed by red. Let me just do it here. So probability of, that's part A red followed by a red is equals to, you can take this one, the first part, top part, is R. It will be 5 over 10 times 4 over 9. Then if we can simplify 5 over 10 times 4 over 9, what do we get? Here 5, 1, 5, 2, 2, 1, 2 into 2. So it will be 2 over 9. That's the final probability. Please take note. You have to simplify your answer. You need to simplify your answer. Right, the second part is saying find the probability of drawing one blue ball and one yellow ball. One must be blue and the other must be yellow. Please take note. In this case, there is no order. It's just a blue and a yellow ball. So how are you going to structure this one? Number B, probability of A is either blue yellow or yellow blue, like this, which is equals to probability of blue yellow plus probability of yellow blue, like this. Then taking the probabilities, blue yellow, you can see from the tree diagram, blue yellow is 3 over 10 times 2 over 9. 3 over 10 times 2 over 9, like this. Then plus yellow blue. Yellow blue is 2 over 10 plus 3 over 9. 2 over 10 plus 3 over 9. Like this. Then simplifying the two, the first part, please, just multiply the numbers on top, right? Just multiply the numbers on top. You can just say 3 times 2, it will be 6. 9 times 10 is 90, plus 2 times 3 is 6. 10 times 9 is 90. The reason why you just have to multiply the top, the numerators, is so that the denominators will be the same. And it will be easier on your side to work this one out. Was just have to add the numerators. You just say 6 plus 6, it will be 12, then over 90. Then this one you simplify. You can use your calculator, or you can just simplify this one using common factors. So in this case, it's 12 over 90. Then as a fraction 12 over 90, if you can simplify this one, it will be by 6. Here it will be 2 over 15. Then you'll be done. So this was part B. Let's move on to the third part, which is part C. This one, find the probability of drawing 2 yellow balls. 2 yellow balls. So this one is just a probability of a yellow followed by a yellow. Let me do it here. Probability of a yellow ball followed by a yellow ball is equals to 2 over 10 times 1 over 9. 2 over 10 times 1 over 9, which is equals to, you can simplify here. 2 over 10 by 2 here 1 by 2 here 5. So it will be on top 1 by 1 is 1. Then 5 by 9 is 45. Like this. Right, then the last part, it reads, find the probability of drawing 2 balls of the same color. 2 balls of the same color. So if they are of the same color in this case, there is no order. Please take note of that. There is no order here in this case. So they must be of the same color. So if they're of the same color, is either they can be red or blue or yellow. So there are 3 different outcomes here in this case. Please take note of that, right? So there are 3 different outcomes in this case. Let me write them down, the outcomes. So the outcomes here, let me wrap this part, because that one will need a bit of space. So it's a probability of balls of the same color. Balls of this 2 balls of the same color. So the 2 balls must be of the same color. So let me write the outcomes here. So it's either probability of they can be red or blue or yellow, like this. Then this one can be simplified to probability of red plus probability of blue plus probability of yellow, like this, which is equals to, right, probability of red, you can see on this tree diagram, is 5 over 10 times 4 over 9. 5 over 10 times 4 over 9, then plus probability of blue on the tree diagram is 3 over 10 times 2 over 9. 3 over 10 times 2 over 9, like this. Then plus probability of yellow, you can see that one on the tree diagram. Yellow is 2 over 10 times 1 over 9. 2 over 10 times 1 over 9, like this. Right, then let's simplify. It will be equals to, just multiply the numerators, please. 5 times 4 is 20 over 90, plus on this part 3 times 2 is 5 over 90, plus this one, it will be 2 over 90. Then after that, to simplify, you just add the numerators. 20 plus 5 plus 7, it will be 27 over 90. Right, 27 over 90. This one, please take note. You have to simplify this one. 27 over 90. You can use your calculator, or you can just use by 9 here in this case. 9 into 27 is 3. 9 into 90 is 10. So your answer will be 3 over 10. Even if you can say 0.3, it's still the same, right? So it's still the same. Please don't worry about that one. It will still be the same. Take note of that. Then let's move on to the third question. Question number 3. Right, this one reads, a 6-sided die is thrown 3 times. Draw a tree diagram showing at each branch the 2 events, 6 and not a 6. What is the probability of throwing a total of? Right, so the first part, or the first thing that you have to do is to draw the tree diagram. And in this case, please take note, these are 3 times. It has been thrown 3 times. And this die is how many sides? These are 6 sides. 6-sided die. So it's just an ordinary die. Otherwise, there's a tetrahedral die that is 4 sides. But in this case, we are working with an ordinary die. 6 sides. Then you want the probability 6 and not a 6. So what you do first is, if you are to throw a die, what is the probability of throwing a 6? Basically, it's 1 over 6. 1 6 on a die over total number of sides, which are 6 sides. Then probability of not a 6, let's use 6 bar. 6 bar, that's not a 6. Then it will be 1 minus probability of a 6. Please take note of that. Probability on the first part, we said it adds up to 1. So the probability of is either, in this case, you can throw a 6 or you cannot throw a 6. It can be a different number. So probability in this case is a 6 and not a 6. If you can add the 2, they must give you 1. So probability of not a 6 is just 1 minus probability of a 6, which is 1 minus 1 over 6, which is equals to 5 over 6. That's the probability of not a 6. Right, let me draw the tree diagram. Let me put this dots. Then the second part. And these ones, take note, please. There are 3 different throws that has been made in this case. So the first throw is a 6, not a 6. Then the second is 6, not a 6. Then a 6, not a 6. So there will be 2, 2, 2, 2, 2, 2 for a 6 and not a 6, like this. Then let me fill this part. This one is a 6. This one is 6 bar, which means not a 6. 6, not a 6. 6, not a 6. 6, not a 6. 6, not a 6. 6 bar. 6, not a 6. This one is a 6. This one, not a 6, which means the 6 bar. Right. So the probabilities, let me just feel, they will never change. They will still be the same. So of a 6, it will be 1 over 6. Not a 6 is 5 over 6. 1 over 6, let me use a different ink here. 1 over 6, 5 over 6, 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 1 over 6, 5 over 6. So, wherever there is a 6, you just have to put 1 over 6. Not a 6 is 5 over 6. That is 1 minus probability of a 6. Take note of that. Then, now to the questions. They are saying, what is the probability? What is the probability of throwing a total of 3 6s? That is the first part. A total of 3 6s. So let's move on to calculate the probability. So please take note. As on number 2, it's probability of 6 followed by a 6 followed by a 6. That's the first part. So 3 6s. 3 6s. There must be 3 6s of them. Then it will be equals to, it's if you can look there, it's 1 over 6 times 1 over 6 times 1 over 6. Excuse. Simplifying this one, you get 1 over 6 times 6 times 6. What do you get? 6 times 6 times 6, you get 216. That's the probability. Please take note of that. That's the final answer. Then the second question is saying no 6s. No 6s. This one is actually easy. Probability of no 6 is probability of not a 6, not a 6, not a 6. Which means 6 bar, 6 bar, 6 bar. Basically, remember I said it's either you can throw a 6 or not a 6 is on this question. So probability of getting a 6 is 1 over 216. What about not a 6? It's 1 minus probability of getting a 6, which is 1 minus probability of getting a 6, 3 6s, which is equals to in this case, there must be no 6s, right? There must be no 6s. So if there must be no 6s, it's a 6 and a 6. It's not a 6, not a 6, not a 6. So in this case, please sorry for this one. This one just straightforward. You just take this branch, not a 6 and not a 6 and not a 6. So it will be 5 over 6 times 5 over 6 times 5 over 6. Because there must be no 6s. No 6s. There must be no 6. So it means no 6, no 6, no 6 on both the throws that has been made. So it's like this. Then you can simplify this one. 5 over 6 times 5 over 6 times 5 over 6. Right? You get here 125 over 216. Right. You have to check. Can this one be simplified? There are no factors. So you just have to leave it like this. Okay. So thank you. With the ego, I say Mangea. Please, after watching, subscribe and also share this video. It's actually nice. Thank you. Thank you. And thank you.